there is the higher shells.
Mm-hmm. The more shells.
So more proton number.
No.
And
Number.
less energy.
Okay. Okay. The higher, the more proton. With increasing proton number, it means increase also the number of number of electron. Okay. So more number of electron, more shells. There is an shielding effect, shielding from the inner shell that prevent the outermost shell to fill the nuclear charge. So the nuclear charge decrease, that makes the ionization energy decrease. Okay. Next,
Wait, teacher, can you repeat it again?
yeah, more more number or more proton means more electrons. Full stop. So let me write. Let me do annotation. Let me do annotation here. More protons equals to more electrons, and then more electrons meaning more shells, more electron shells. More electron shells meaning less, more inner shielding and less nuclear charge. So if there is more shielding, less nuclear charge, the effect less first ionization energy. Yeah, less ionization energy. Okay, so that is the meaning, the way how to answer this one, and then think. Okay, okay, Brian.
Teacher, may I ask?
The teacher.
Yes, of course.
More inner shielding. Is it like there's like a stronger attraction for the like inner electrons compared to the outer electrons?
Yes, correct. So inner electrons, the inner elect, the inner electrons prevent outermost electron to fill the attraction with the nucleus.
For them to like to get removed.
If the electrons in the outermost feel less nuclear charge, so the outermost electron is easy to lose, easy to run away. That makes
Okay,
it
teacher.
easy to run away. It makes the first ionization energy decreases.
Thank you, teacher.
Yeah. Okay. Next, next question. Next question. This one. The periodic table we currently use is derived directly from that proposed by Mendeleev in 1869. After he had noticed patterns in the chemical properties of the elements he had studied. And then the diagram below shows the first ionization energies of the first 18 elements of the periodic table as we know it today. Give the equation. Okay, in here before we give the equation, look, please see this this one, these elements. See these elements here. These elements here consist of three periods. This is the first period elements. This is the second period, and this one is the third period of elements. As we can see here, the general pattern, we see the general pattern from here to here, from across the period increase. And then also general, this is general trend. If there is general, it means there is an exception. General trend increases from lithium to neon. If you when you take a ruler and then draw the line, it shows increase. And then also with sodium, this one also increase. But there is an exception. This one, and then exception, this one, and then except this one, and then also with this one. What is the general of the exception? Look at this one. Between these two exception, right? This one and this one. It occurs on the between second and third group. Group 2, between group 2, group 3. This is 4, 5. So between, again, this exception again is in group 5 and group 6. So group 5 and group 6. Group 5 to group 6, there is an exception. Group 2 to group 3, there is an exception. The exception will be asked in this question. Now give the equation including the state symbol for the first ionization energy of fluorine. First ionization energy of fluorine. Let me ask to Sherry. What is the first ionization energy equation for fluorine? Hello, Sherry. Okay, then let me ask to Clarabella. Hello, can you hear my voice, Clarabella? Hello, Clarabella. Oh, let me ask Eric then. Eric, can you hear my voice?
Yes, teacher.
Okay. What is the first ionization energy equation for fluorine?
I don't know, teacher.
Okay. The first ionization energy is energy required to remove an electron. So this one, we need to know that when fluorine is an element. The element, in order to undergo ionization, the fluorine element. So the fluorine element must fluorine. This one as F2, and then this one as a gas. It must undergo atomization to F gas, and then the first F gas, okay, F gas is already become an atom, and then become F because it lost an electron, so become F plus gas, and then plus E minus. Okay, so this is the first ionization energy for fluorine. Okay, then let me ask to Felicia.
Yes, teacher.
Okay, number B, Felicia. Number B, you need the graph. Explain why there is a general increase in first ionization energies from sodium to argon. So with this one, with yeah, sodium.
Sodium and argon are located in the same period.
Yeah,
Sodium is located on the most left and argon is located on the most right.
yeah,
So from sodium to argon, there's an increase in the number of protons and
yeah.
electrons. As a result, there would be more electrical charge, and so a greater ionization energy will be required to take the electrons away.
Okay, where in which part are you going to put the phrase shielding effect? What happens with the
As
shielding?
we, as we go to the right, there will be more electrons, and so there will be more electron shells.
Are you
And
sure?
this is more electrons, more electron shells.
Across the period, more electron shells? Are you sure?
More electrons.
More electrons, but not more electron shell.
Yes.
Yeah. Then, how about the shielding?
Um, the further away the electron from the proton, the more the shielding effect.
The more shielding. If more
Yes.
shielding, more nuclear charge, more shielding, more nuclear charge, that is contradictory to the theory, Felicia. Contradictory to
So
the theory.
less shielding effect, so more nuclear charge, and it's harder to separate the electron. So
Yeah.
a higher ionization energy is required.
Yeah. Why is it less shielding effect?
Because it's more further away from the nucleus.
Less? No. If further away from the nucleus, the shielding effect greater.
Oh.
Yeah. It should be greater. It is not the less shielding effect, Felicia. It is the same shielding effect. Shielding effect. It's written on the subtitle on our textbook. Is written shielding inertials. Am I right? Shielding inner electrons. And then it means that the one electron shells can make a shield on the other outermost electron shell. So, therefore, across the period, the shielding effect will be the same. Shielding effect across the period will be the same. But the nuclear charge increases because more electrons and more protons, so they have more attraction.
Teacher, is nuclear charge different from electrical charge or the same?
Electrical charge is positive and negative. That is electrical charge. If nuclear charge is the charge of the from the nucleus only containing positive, it does not contain negative.
Oh, okay.
Do you get confused, Felicia?
A bit
Wait.
because the one from the video was it said about electrical charge. That's why I said electrical charge just now.
Oh. It is this chapter. This chapter is started to make you confused because
Yes.
structure of atoms is different perspective, different from how we study in grade 9, grade 10. Grade 9, grade 10 was only the basic, very basic. This one is a bit advanced, just a bit, not too advanced. Okay, and then now number C1. Number C1. Okay. Let me ask to Clarabella. Hello, Clarabella. Hello, Clarabella. Can you hear my voice? Okay, let me this one make it bigger. Okay, sodium to argon already finished. Okay, Clarabella. The C.1 Ci. Explain why the first ionization energy of aluminum is less than that of magnesium. Aluminum is less than magnesium. Okay, before answer this question, let's see the fact. You have your data booklet. This data booklet is our tool. On the data booklet here, this is the first page. This is the fact, the important values, constant and standards. These are the standards that we are going to use, and we have some we used already. Okay, now this one, ionization energy. This is the sheet between aluminum and magnesium. Okay, between aluminum and magnesium. So it was written aluminum and magnesium. here. These two. Okay. Aluminium is in group 3. Magnesium is in group 2. From magnesium to aluminium, the ionization energy should increase. But in this one, decreases. Okay, decreases. 736 for magnesium and aluminium 577. How to explain, Clarabella? Okay, let's see the question. Hello, Clarabella? Maybe Clarabella has your microphone.
Salute.
Hello?
Salute.
Oh, is it Nathan V?
Hello there, just got a new microphone.
Oh, that's good. Got new microphone. Okay, Nathan V.
Yes, sir.
Clarabella, can I hear your voice? Okay, then let me ask Nathan V.
Yes, sir.
Okay, Nathan V. Why is the first ionization energy of aluminium less than magnesium?
The first ionization energy of aluminum is less than magnesium, right?
Yeah.
So if you see the periodic table, we can see that. Wait 1 minute. Let me search. Let me search for the periodic table. Wait. Aluminum and magnesium. So basically, magnesium and aluminum. Aluminum is in group number 13, and magnesium is, well, it's very simple. Just because aluminum has more numbers of electrons around it, and therefore it would have less diameter of the atom. Magnesium will have more. So if we remember using this spinning quantum thingy, so we have the boxes thingy thingy, right? So there
Yes.
is the rule. The rule goes like this. So basically, more boxes that are filled means that it will have a stronger bond of attraction,
Oh,
and this means that it requires more ionization energy, which
wait.
aluminum has because three.
Nathan V. Nathan
Yes,
V. Are you using your laptop or are you using your desktop or are you using your phone?
my desktop, sir.
Or desktop? Then you can do annotation. Have you ever done?
Yes, sir.
Okay.
Notation.
Yeah.
Uh,
You click on the annotation and then I will permit it.
okay.
So you can explain using your annotation.
Okay. All right. Let me try to do this annotation thingy. I don't know how to use annotation, but I'll try.
Annotation is on this one on the screen. There is mute me, video recorder, participants,
Okay.
chat, and then next is annotate.
Noted. Uh,
Find the button.
I can't find the button. Share content. Mute. Stop my video. Share content. Participants. Chat and more options. But
More option. Click more
more
option.
option.
There is
Yes.
annotation. Annotate.
No. I can't find it, sir.
Oh, okay. This one. So aluminium is 13. Aluminium has 13 electron. Okay, aluminium is 13 electron. and then magnesium has 12. Magnesium has 12 electron. Magnesium has 12 electron, and then we know aluminum is consisting of 1s2, 2s2, 2. So aluminum is 1s2, 2s2, 2p6, and then 3s2, and then 3p. How many, Nathan?
8, and then finally 3s1 for aluminium. It will be like
3p
7. Wait, 7, 8, 9, 10, 11. 8.
3p1.
Wait, I forgot for the aluminium. I have forgotten to write 3s1. So wait, 3p1.
Okay,
3.
it is aluminum is having 3p1, and then this one magnesium is 1s2, 2s2,
2s2,
2p6,
2p6, and
3s2,
3s2.
and then only 3s2.
No,
Yeah, look at from this one. P orbital has more energy than S orbital. That's number one. So this one has more energy than this one. 3s2. Second, P electrons in the p orbital has more shielding compared to electrons in the s orbital, because electrons in the p has more shielding. That makes the first ionization energy decreases. Okay, I understand. Nathan V.
I understood, sir, completely.
Okay,
So can you repeat again?
okay. Aluminium is ended with 3p1. Magnesium 3s2. P electrons in p orbital, they have higher energy than in orbital s. But s orbital has more nuclear charge than in p orbital. Or in other words, p orbital has more shielding. That makes the aluminum has less first ionization energy. Okay. Similar reason, Nathan V, there is no 2p8. There is no 2p8.
I forgot about that. I mean,
Yeah. The maximum electron in p orbital is only 6.
yes.
Okay. The third one. Explain why the first ionization energy of sulfur is less than phosphorus. It happens, as I told you earlier, that there is an exception from group 2 to group 3. And the second exception is from group 5 to group 6. P and S, they are in group 5 and group 6. Okay, so they are in group 5 and group 6, P and S. So there is a decrease. There is decrease. This one, let's see. Sulfur is less than phosphorus. Also the same. Sulfur has 16. Sulfur has 16 electrons, while phosphorus has 15. Okay, and then we write here sulfur has 15 electrons, which is 1s2, 2s2, 2p6, 3s2, and then 3p3. And then S, oh sorry, not S. S is having 16 electrons. 2p4. And then phosphorus has 15 electrons, which is 1s2, 2s2, 2p6, 3s2, 3p3. Oh, 3p3. From these two, okay, 3p4 and 3p3. If you draw the electron, the orbital p, this one has 3 orbitals. 1, 2, 3. And then with this one also 1, 2, and then 3. Remember that P, there is Px, Py, and Pz. So P, this one, 1, and then 2, and then 3, and this one more here is drawn. We have to draw, it is the fourth one. 4. Well, this one, 1, 2, 3. Electrons in here only containing, each orbital contains only 1 electron, but they have the same spinning direction. Spinning direction the same, clockwise. In this one, there is an electron that has different spinning direction from the other 3 electrons. That makes this electron that has different spinning direction is easy to be removed. Okay, easy to remove. What is the effect if it is easy to remove? Then, if easy to remove, it means it will have less first ionization energy. Okay, understand? Natasha?
Understood, sir.
Yeah.
So this is the boxes, the arrows in the boxes rule, right?
Yeah.
Just
Yeah. There is
so
one electron with different spinning direction.
ah
Okay.
okay.
And then this one, and then this one. Next question. Now this one is energy level. This one energy level, we have to label the energy level to indicate the principal quantum number. Principal the quantum number, it means is only asking for the that one. This is written 1s. No need the how many electrons because quantum is this one. After 1s, then there is a 2s, and then 2p. P there is 2px, and then there is a 2py, and then there is a 2pz. Okay, there is a 2px, 2py, and 2pz. And then on the next diagram, this one shape. We know that shape this one, if it has three shapes like this, z, y, x, then this one must be belongs to orbital p. So we have to draw x, or you can draw y, or you can draw z and y, okay, or z and x, okay. And then for the last page, now nitrogen and oxygen, I'm sure you can draw the arrow and you can explain between nitrogen is group 5, oxygen is group 6. So 5 to 6 there is an exception. The first exception was phosphorus and sulfur, and then the second, this one exception which behave the same is nitrogen and oxygen. Okay, I'm sure you can state the reason. Okay, before the class end, let me see the attendance record. uh, Vedika is here, and then there is Ariella, Beatrix, Bavia, Brian, Sherry, Clarabella, Eric, Felicia, Hardy, Kimberly, Lawrence. Matthew Chandra is not here. So Matthew Chandra is not here. Michelle here. Nargis here, Natasha here, Nathan V here, Timothy, Tishel, Vanessa, Vedika. Okay, and Sharon. Okay, Sharon is also not here. Okay, I will discuss more on this topic. I have prepared for tomorrow. We will discuss again tomorrow. Okay, good afternoon, students.
Thank you, teacher.
Good afternoon. Thank you, teacher.
Teacher.
Yes, sir.
Yes. Okay. Now what I need to do is crossing it. Stop sharing. stop sharing, and then I will